Welcome to the Women Who Code podcast. I am Ashmi Banerjee, a PhD candidate at the Technical University of Munich, specializing in recommender systems research. Today, we will explore the topic of fairness and biases in recommender systems. First, we will start by understanding how these systems work, and then we will look into identifying the different stakeholders that are involved in this whole recommendation process and the challenges and the importance of fairness. But we will also afterwards delve into the more effective bias mitigation strategies. So, join me as we navigate the fascinating world of recommender systems, aiming to promote fairness and inclusivity in this ever-evolving technological landscape. Let's get started. So, when we talk about recommender systems, I'm pretty sure that all of you have used it in some form or the other, with or without knowing what it is about. So, for example, I'm sure that in today's era, you have come across systems that help you buy products, for example, Amazon or eBay, or even in the social networks, which recommend you for the newsfeed or the friend recommendations, such as Facebook, Instagram, Twitter, etc. So these are all different forms of recommender systems, from travel to e-commerce to movie recommendations such as Netflix or Spotify, like for music, or YouTube for both. Everywhere it's a recommender system. So what is a recommender system? A recommender system is something that basically provides personalized suggestions to the users. They use a variety of criteria such as past purchases, search history, demographics, etc., to recommend a variety of items to the users. One of the most important uses of recommender system is to minimize the information overload. Often the users on the web are presented with numerous choices, and they really don't know which one to choose from. And that's exactly where these recommender systems come into play. They take into consideration all the data that they have about the users and their preferences and try to recommend things that the user might like. However, these recommender systems are kind of a multi-stakeholder environment, which encompasses different stakeholders. So a stakeholder in case of recommender systems is any group or individuals which are affected by, or they can affect the delivery of recommendations. In a conventional recommender system scenario, there are typically three major stakeholder classes: the consumers, the item providers, and the platforms. Now, let's try to understand this with the help of an example. Let us consider the use case of hotel booking. So as a user, let's assume that you would like to book a hotel on one of the very popular websites such as booking.com. Or it can also be, say, Airbnb, for example. I mean, you choose. In that case, this user becomes the consumer because they are consuming the item. And the item in this case is the hotel or the accommodation that the user is looking for. Quite obviously, the platform or the website where the user is looking for the recommendations become the platform. In the whole process of recommendation, each stakeholder has a vested interest in this process of recommendation. The travelers, for example, they want to find hotels that match their preferences. The hotels want fair exposure to attract their guests, and booking platforms, they also would like to maximize the commission that they receive from these hotels and to maintain like long-term relationships with both the users as well as the hotel providers. And these stakeholders, they all depend on each other for their economic well-being, and therefore this whole booking platform must consider the needs of all stakeholders when recommending the generations. which makes this whole recommendation process a very complicated process. Therefore, the goal of the recommender system should be to consider the needs of all the stakeholders that are involved in this process. That's actually the ideal scenario. But what happens in reality? Let's have a look. In reality, the recommender systems applications have often been responsible for sparking different controversies. For example, some years ago, Amazon had an automated tool to screen applicants for its job interviews. However, after some time, they realized that they were getting fewer female candidates compared to their male ones. An investigation revealed that the automated screening model was biased against women, as it was trained on historical data. This historical data was heavily dominated by male applicants owing to the fewer number of women in tech, which is exactly the reason why we have organizations like Women Who Code, which are working towards empowering more women in tech. And even though Amazon took immediate action to mitigate all these things, like so that there is no more bias, these scenarios are still very, very common in real world. Another example is of the Facebook's ad delivery algorithm, where research shows that it is very discriminatory in nature. So for example, if you would include a picture of a woman versus a picture of a man, in general, it will go more to, it was discriminatory towards women on the basis of race, gender, and age on the photos. Similarly, like other platforms such as YouTube or Spotify have often been accused of prioritizing specific playlists or artists over others, which often lead to a disparity in the exposure and popularity these are received by the items. This brings us to the following question: what causes this behavior? The causes for such a biased treatment of specific stakeholders can be attributed to several reasons. One of them could be like statistical or data bias. So if your data is biased, for example, in the case of Amazon, we saw that it was trained on a data set where they had very few female applicants or female data. Therefore, the model, when it was trained on such a data, it learned that to be discriminatory towards women. And this is a very, very common scenario. And these recommender systems are trained on such a data which is in some way biased towards one or several stakeholder groups. And then these systems learn the patterns and try to propagate them. Other options or other causes could be, for example, cultural bias, so which are, say, interpretations and judgments which are acquired throughout our life, for example, some racial or gender or sexual or other biases that we may have, and then it transmits through us into the data, and then finally gets reflected in the system. There can also be cognitive biases, for example, systemic pattern or deviation from the norm or rationality in judgment, and also confirmation bias, which is the tendency to favor information that supports one's existing beliefs. So these are like some of the biases that are very, very common in machine learning or information retrieval scenarios. However, when it comes to specifically recommender systems, we have two more such biases which are additionally relevant in this case. One of them is popularity bias, where the popular items are repeatedly recommended, creating a self-reinforcing cycle of popularity. So, for example, earlier I mentioned this case of Spotify or YouTube, where certain tracks or certain items are being recommended more often than the other items, and that may lead to like some items receiving more popularity than the others. So this limits the diversity of the recommendations and also restricts the user's exposure to new or niche content. So the user is often like very limited to what they are getting in terms of recommendations. So we did some research, and then our research showed, so we did some research based on the data sets from Yelp, and our research shows that the top rated restaurants of Yelp, they get way more exposure, irrespective of their ratings, than the ones that are not so well rated. So the less popular restaurants located further away from the popular areas of a city, they receive way less exposure, even if they are like very good quality in terms of the ratings. Similarly, another popular bias that exists in a recommender system is called ranking bias or position bias. Recommender systems generate a ranked list of results. So when the user interacts with the items in this ranked list, it is often seen that the user only interacts with the top items of the list and not the ones that are located at the bottom of the list. For example, how many of you would go and check out the items on the second page of your Google search? Yeah. Situations like this often results in position bias, where the user's attention is only concentrated on the popular item. So less exposure is received by the items that are ranked lower in the list. We also did some research using the Trivago dataset, and we that was made public during the ACM Rex's Challenge of 2019, and it showed that the people tend to click on items at the top of the list much more often than the ones that are located below in the list. And this actually confirmed the existence of position bias also on these platforms. So we talked a little bit about the reasons why the platforms behave in a way that they ideally should not. But now it brings us to the next part, that what could be done to fix these problems. So an easy way to fix these problems is by being fair to all these stakeholders, which leads us to our next question: how do we define fairness? So fairness concerns actually how the outcomes are assigned to a particular group of individuals. And it is often a political construct where someone decides to avoid direct or indirect harm to people. However, the challenge is that there exists a multitude of definitions of fairness for algorithmic decision making. And it's super hard to narrow down to a specific definition that will work for all the use cases. On a high level, the fairness definitions can be divided into individual and group fairness notions, where, as the name suggests, group fairness ensures that fair treatment of similar subjects within the different groups based on certain protected attributes such as race or gender, etc. While individual fairness assesses whether individuals are treated fairly by ensuring that similar subjects receive a similar decision outcome. As I mentioned before, that recommender systems is a multi-stakeholder environment. Therefore, to ensure fairness in recommender system should also be a multi-sided concept that considers the needs of all the stakeholders. As I said before, the definition of fairness, again, can vary depending on multiple factors and must be determined on a case-by-case basis. So why do we think that we need to be fair to while we are actually recommending items or basically like allocating certain resources? Because recommendation of the items is actually a certain way of allocating limited resources. So recommendation slot positions are limited, as I said before, because as you go further down the ranking, your users' attention drastically drops, and also the probability of that item be recommended or be liked by the user also drops. So this means that the items should be recommended at the top to get the exposure opportunity that they deserve. This is the reason why it is needed that the ranking of the items be fair, so that they get the exposure that they deserve. The next issue is that often there are an abundance of options, but only one recommended solution. For example, when we look at the use case of matching drivers to different passengers to maximize their profit with limited passengers, or say, for example, when we have to choose a single candidate from a pool of applicants for a single position, and then the whole thing becomes really hard. And then if you can't do it in a fair way, in that case, it might affect the life or it might affect the life of a particular individual who's looking for that job. So hence we should not encourage unfair practices, but we should actually look into fair practices and make sure that our systems are fair. Some other consequences of unfairness in recommended systems could be attributed to information asymmetry or harm of allocation. As I said, that if a certain group is allocated or deprived of certain opportunities by a certain system, despite it being a deserving candidate, for example, in the case of a job opportunity, which can change someone's life, this is very important that the whole system takes into consideration the ranking in a very fair way. Another aspect is known as the Matthew effect or the harm of representation. This is a very common thing. Actually, when you search on Google for images of a nurse, most of the results show images of women. This is something, first I read about it on the internet, and then I did a search myself a few weeks ago, and I realized that nothing actually has changed. If you look for images of nurses on the web, then you will find that majority of the images are of women. And this actually reinforces the subordination of certain groups along the lines of identity, such as gender, race, etc., and also promotes stereotyping that, okay, so whenever we are talking about nurse, it's always a woman. Even I think I came across it recently that LLMs such as ChatGPT, since they have been trained on massive amounts of data, they are also biased in certain ways. And if you talk about nurses, they often refer to it as a woman. So yeah. The third one is stereotyping, obviously. So the formation of echo chambers or stereotyping, where we associate a certain type of behavior with a certain group of people and then trying to treat them very differently from the way that they deserve. This actually makes people feel like the whole world feels like the way they do. So they are basically in their own bubbles. And then it prevents them from exploring new ideas, opinions, and other ideas. So yeah, we talked a lot about what are the bad influences of unfairness, so how it can affect the recommended systems and also our lives. But this brings us to the next part. How do we actually mitigate this? So there could be some high-level strategies in recommender systems which can be used to mitigate unfairness and also the biases that exist in this systems. One of them could be the algorithmic strategies. So we are all computer scientists, so we use different algorithms to train our models. And one way would be to use such algorithms so that the bias is reduced. Algorithmic strategies include like pre-processing, which includes transforming the data to eliminate the underlying discriminations. Then it can also be like in processing, where we try to modify the learning algorithms during the training period to prevent discriminations. So the last but not the least, it can also be post-processing strategies where we perform post-training evaluation on a holdout set that has not been used in the model training process. Another interesting way of bias mitigation could also be the use of explanation. A lot of the different platforms actually use this process. For example, we are very familiar with statements such as, this digital camera is a must buy for you because you probably bought so and so or something like that, right? And these explanations help you understand why an item was recommended to you by the algorithm. So they help you in decoding the black box of this whole recommender system algorithm. The advantage of using such explanations is obviously transparency. So you know that something is not recommended to you out of the blue, but there is a certain reason why the thing was recommended to you. It also helps to make the system a lot more trustworthy, and it can be used by the system for persuasiveness. So to trying to persuade the user to buy certain item or behave in a way that the system actually wants the user to behave. And last but not the least, it also helps the user to make an effective decision. So it aids in this effective decision-making process. The third category of trying to mitigate biases is the more generic things that you should do while you are training your models or working in this area. These are some of the generic best practices that you can possibly undertake. For example, when you are starting off, it's best to check for dataset imbalances if there exists something, and then to immediately mitigate that or try to mitigate that so that it does not influence your results afterwards. The other one would be to ensure that the model treats all the groups fairly. You should try to understand the model behavior and try to monitor the prediction and see whether the model is behaving in a way you expect it to behave, or it has some sort of an unexpected behavior. And from time to time, if it's necessary, then please retrain your model on new data or updated data. So as we conclude this journey into recommender systems and this very crucial topic of fairness and biases, I hope that you have gained some valuable insights and a better understanding of these algorithms and their ethical challenges. Just a quick recap. Today, we explored the foundations of recommender systems, followed by the stakeholders that are involved in the whole process, as well as some of the complexities that are faced in achieving the idealistic goals in the real world of recommender systems. We also delved into the pressing issues of biases and the extreme importance of ensuring fairness in these systems to create a more fair and equitable digital space for everyone. So yeah, and remember that the impact of these recommendation algorithms, they extend far beyond the mere suggestions. They influence our choices and preferences and even shape our worldview. Therefore, it is very important for us to ensure that these algorithms are fair and they are treating each of the stakeholders that are involved in this whole process in a manner that they deserve to be treated. So with this, I come to the very end of my talk. I have compiled all the resources that I have used for this podcast under bit.ly fair-rs. They are also available in the description in case you are interested for a more detailed read. I hope you found this talk informative, and thank you so much for listening. Bye.